We spent a lot of time on this channel thus far talking about the big players of the graphics card market in the late 90s and early 2000s. Of course, everyone here knows who Nvidia is, and probably also knows who ATI is, despite the name disappearing about 10 years ago. You probably also know of 3DFX if you were around in those days or enjoyed retro tech. But there's another name that, if you weren't already, you should probably be aware of. Have you ever heard of Imagination Technologies? This is PixelPipes. In a nutshell, Imagination Technologies is the company that produces PowerVR products. In recent years, PowerVR GPUs have powered the graphics of many smartphone and tablet SoCs, or systems on a chip. As of 2020, it seems their newest A-series GPUs will finally put to rest the PowerVR brand, a name that, well, not as synonymous with graphics in the minds of mainstream tech consumers as Nvidia or AMD, has nonetheless been a staple of the industry for decades, lurking ever presently in the background.
Founded in 1985 under the name VideoLogic, the company based in Hertfordshire, UK, started off making a variety of expansion cards and other computer hardware largely for business customers. In 1996, much of the PC world was lusting after the prospect of 3D accelerated graphics, and like so many hungry-eyed companies at the time, VideoLogic was at the ready with their own solution, which they called the Midas 3. But with an extremely limited distribution in some compact PCs and very poor game support, this initial entry didn't get very far off the ground. Undeterred, they would continue development of the product, quickly following up with a more refined PCX1 later that year, which actually saw a retail release as the Apocalypse 3D, fitting in well with the attitude of the 90s. The PCX2 would follow that in 1997 with improved speed and bilinear texture filtering support. Early PowerVR cards all had one notable characteristic, and that was their lack of any VGA output or input, acting purely as internal 3D accelerators that passed the rendered image digitally via software over the PCI bus to the 2D accelerator's frame buffer. For more info on how that worked, you should check out this excellent video on the PCX2 by Vlask in the link above.
VideoLogic would eventually be renamed to Imagination Technologies in 1999, coinciding with the launch of the Dreamcast that year, a major milestone for the company as Sega's cutting-edge console would utilize their PowerVR technology for its graphics hardware. On the PC side, however, they were less successful, as while they would continue to refine and release better and faster hardware, their products never seemed to make much of a dent. But with the onset of the new millennia, they were hoping to change all that with a third series of 3D accelerators known as PowerVR Kyro.
The STG4000 Kyro, as its chipset was known, would improve on previous designs in nearly every aspect. Fundamentally, the biggest improvement was the doubling of the rendering pipeline, which also doubled the texturing capabilities. They also greatly expanded the feature set, allowing for 8-layer multi-texturing, S3TC/DXTC texture compression, environment mapped bump mapping, ordered grid super sampling anti-aliasing, and 2x anisotropic filtering. Specs-wise, the first generation Kyro, or Kyro 1 as I'll be referring to it, was clocked at 115 MHz for both its core and memory, with the memory being 32 or 64 MB of single data rate modules. That's not great, and would have been considered mediocre by 1999 standards, let alone 2000. You can see here that the specs and fill rates compared to a top-end GeForce 2 at the time were utterly abysmal. But the key to Imagination's strategy was price. The Kyro 1 wasn't priced in league with high-end cards, it was marketed towards the budget users. Starting at $60, there were few graphics cards on the market for such little money that could give you the performance that Kyro was offering. Right off the bat, Imagination partnered with Hercules to deliver cards to retail, a respected board partner of the time, which lent the product line their distinctive blue PCB aesthetic, which always managed to make even the cheapest cards feel premium. While the specs may not have been impressive, the Kyro series was never about making the hardware faster, it was about making it smarter. To that end, they retained an important feature from the previous generation, known as tile-based rendering. This differed from virtually every other architecture of the time, which used immediate mode rendering, a method of rendering an entire scene at once. By contrast, tile-based rendering broke the scene into smaller chunks for more efficient rendering. The Tech Report's Jeff Gazier explained it better than I ever could in an article from 2001.
The Kyro's tiling technology segments the screen into 32 by 16 regions, each region with its own buffer. The chip pulls all the triangle data for the scene, including those triangles that aren't visible, and performs something called binning. Binning determines which tiles a triangle is located in and stores a pointer to that triangle in the tile's buffer. Now that we have everything binned, we move on to the hidden surface removal, which will determine what we can and can't see in the scene. HSR pulls information on all the triangles in a particular tile from that tile's buffer, and then figures out which triangles are in front. The end product is a buffer containing pointers to only the visible triangles that determine the appearance of pixels in the scene. This is what gets rendered to the screen.
He goes on to explain that once the triangles are binned and the hidden surfaces are removed, only then is the texturing applied, a method known as deferred texturing. By saving this step for last, only the visible surfaces receive texturing, and the same goes for lighting. This greatly saves on overdraw and thus performance, something crucial given the Kyro's fairly modest hardware resources. With only 2 pipelines and 2 texture units, the fact that the hardware supports 8-layer multi-texturing was a very impressive feature. Once again, Jeff explains that this is accomplished using the chip's tile buffer mentioned earlier, allowing it to store 2 textures in the buffer with each pass, and apply additional textures up to 4 more cycles without having to do full geometry rendered passes each time. Additionally, while you can choose 16-bit color mode as an option, the hardware will always render internally with 32-bit colors. Quickly after the release of the first Kyro, the Kyro 2, or STG4500, was launched in 2001, shrinking the manufacturing process from 250nm to 180nm, and greatly boosting the core memory clock to 175 MHz, while keeping the rest of the specs the same. This card was positioned above the original Kyro and sold alongside it, with prices starting at around $110. The competitive landscape at this price was much more intense, with both ATI and Nvidia offering multiple products within close proximity of its performance.
One crucial omission of the Kyro line, however, was the lack of hardware transform and lighting. Although the Kyro series claimed to have full DirectX 7 support, and even some features beyond that, such as environment-mapped bump mapping, the lack of hardware TNL made their architecture, in the view of some, more like a souped-up DirectX 6 architecture. Competitors like Nvidia latched onto this fact, producing an internal document sent out to reviewers and PC builders warning them against the Kyro 2, calling it a very old design that was risky to buy and designed by committee with hacked-together boards and poor game support. But in reality, the games you'd likely play on the card were rarely, if ever, affected by compatibility issues related to the architecture or the lack of hardware TNL. And as for performance, well, what do you say we take a look at that?
The cards I've chosen for this lineup are both options that most closely resemble what was available at comparable price points, as well as cards that are simply interesting to include for mostly academic purposes. The original Kyro with 32MB of memory was widely available between 2000 and 2001 for around $60 according to reviews, with one power color model coming in at $80, with 64MB versions adding around $20 more. Price-wise, its closest competition at the time was Nvidia's GeForce2 MX, later renamed to MX200, and ATI's budget-oriented Radeon SDR and Radeon VE, all at or slightly above $100, meaning the Kyro generally undercut its competitors. I should also note that the MX200 had a very wide range of configurations, with some sporting DDR instead of its generally more stock SDR configuration. And the latter is what I chose for more reference level performance, but you can easily find models that are significantly faster. The Kyro 2 was widely available starting in 2001 at around $149 with steep price drops to follow. Its closest competition was the Radeon 7500 and GeForce2 Ti, but both were generally more expensive, in some cases significantly so, depending on the model. The Radeon 7500 in particular launched at $200, but would see significant price drops in the several months following. All Kyro cards were available with PCI variants, and while I've tried to procure some, they're fairly rare and often expensive, and they have significant chipset or CPU compatibility issues compared to their AGP counterparts. I have a 32 and 64 meg version of the Kyro 1 on PCI, but only the 64 meg version wanted to work in my test system, so that's what I used. PCI variants also tended to cost more when they were in production, which would throw off their competitive standing somewhat. In addition to the aforementioned cards, I've also included the GeForce2 MX400, which performs significantly better than the standard MX200 and mimics a GeForce 256 very closely. I also threw in a GeForce2 GTS 32MB since it's a high-end offering from 2000 that's easy to find, and a Radeon DDR64MB since that was ATI's top contender of that year, and of course a Voodoo 5 5500, since you can never have enough of that card in videos like this, or anything really. Just as a reminder, here at PixelPipes we intentionally use overpowered CPUs and newer, but not always the newest drivers, which are more mature and perform better than what was available at the time of launch, in order to get as close to each graphics card's true potential performance as possible. Please check the video description for test system details. In 3D Mark 99, you can see both Kyro generations perform extremely well next to their relative competition. The first Kyro absolutely creams the GeForce2 MX200, while the second gen Kyro beats the GeForce2 Ti by around 150 points. The PCI Kyro drops off more than half the performance of the AGP versions, which is not a great first impression. None of the Radeon cards fare particularly well here. In 3D Mark 2000, you can see the gaps in performance widen quite a bit, and here the Kyro 2 doesn't stand quite as strongly against the GeForce 2 series, getting firmly beaten by the Ti variant, and even the Radeon 7500 takes a hefty lead. The Kyro 1 does a better job against its competition, beating the Radeon SDR and Radeon VE, and makes an embarrassment out of the MX200. Hell, even the PCI Kyro gets close to the MX200. The PCI Kyro unfortunately stumbled the next time around, failing to run 3D Mark 2001 without getting an error message when I tried to start it. The AGP version ran it just fine, however, beating the Radeon VE and more than doubling the score of the MX200, but falling just slightly behind the Radeon SDR. The Kyro 2 is rather disappointing here, losing by an even bigger margin against the Radeon 7500 than it did in the previous test. The GeForce 2 Ti also beats it, but not by quite as much. On a side note, I still can't get over how well the Voodoo 5 does here, with unoptimized drivers still managing to beat the MX400 and edging close to the Kyro 1 and Radeon SDR. Quake 2 is not a good look for the Kyro cards, especially the Kyro 2, which falls way behind the Radeon 7500 and GeForce 2 Ti. The Kyro 1 gets a few more frames than the Radeon VE, but falls well short of the Radeon SDR, which while positioned as a budget offering was still a beefy card for its time, being based on ATI's high-end R100 GPU. The Kyro's saving grace is the abysmal MX200 performance, which even trips up trying to catch the PCI Kyro. Quake 3 is even tougher on the Kyro bros, with the Radeon 7500 more than doubling the performance of the Kyro 2, and both the Radeon SDR and VE comfortably beating the original Kyro. What's even more stunning is how the PCI version of the Kyro performs identically to the AGP version, indicating to me at least that the drivers have some serious performance hindrances with these id Tech engines. I mean, the freaking Voodoo 5 performs nearly the same as the Kyro 2. Unreal Tournament looks a lot more normal, and here the Kyro 2 performs much more closely to its competition, getting beat by just under 20%. The original Kyro doesn't do as well, beating the Radeon VE by a few frames, but losing by a lot against the Radeon SDR. The MX200 continues to perform like crap, leaving the more expensive MX400 to clean up after it, which does manage to beat the Kyro for a decent chunk more money at the time. The PCI Kyro doesn't run this game at what I'd call a silky smooth frame rate, losing to all but the MX200, which isn't saying much. Need for Speed Porsche Unleashed has quickly become a staple benchmark on this channel, and the Kyro cards run it reasonably well. The Kyro 2 once again comes up short against the 7500 and GeForce 2 Ti, but still runs the game very smoothly. The first Kyro doesn't do as well, losing by a big margin against the rather impressive Radeon SDR, but still managing to put the pitiful MX200 in its place. More alarming is how well the PCI variant does here, either indicating that the game doesn't care much about bus bandwidth, or that the AGP version should be performing better if not for its drivers. Slave Zero caused some problems for a couple of the cards in this lineup. For whatever reason, the Radeon SDR refused to run the game even after trying multiple drivers, but its brothers, one of which shares the same GPU, ran it without problems. The Kyro had the same problem, even though the nearly identical PCI variant did so without issue. The Kyro 2 gets reasonably close to the Radeon 7500 here, but the GeForce2 TI has a greater lead, likely O2 16-bit color playing to its strengths. Probably for the same reason the MX200 shockingly manages not to drunkenly collapse on the floor and choke on its own vomit, but the PCI Kyro still beats it anyway. And lastly, we have Expendable, and this shows probably the best results yet for the Kyro 2 in an actual game, nearly matching the GeForce2 TI and nipping at the heels of the Radeon 7500. The Kyro 1 also performs well, almost matching the Radeon SDR and doing a good deal better than the Radeon VE. The PCI version does lose quite a bit of performance, but still runs the game relatively smoothly. We won't even talk about the MX200.
So how can we conclude the performance results of the Kyro series? Well, you have to understand that performance of a given graphics card has to be evaluated relative to its cost. In the case of both the original Kyro and the Kyro 2, these were budget offerings being sold at a time when there were few good options at their respective price points. In most tests, while they didn't perform as well as the cards I pitted them against, they were usually found for cheaper.
But that situation gets muddy when you consider that prices were constantly fluctuating. Their competition from both ATI and Nvidia would see many price drops, and by 2002 the Kyro series started to look a lot less appetizing. Cards like the Radeon SDR or Radeon 7500, which debuted at $150 and $199 respectively, could be found at or under $100 by then. The GeForce2 TI, which debuted at $179, could later be found for around $115. All too often, this is what happens when a newcomer tries to enter the graphics card market. Their best technology, limited by time and budget constraints and the number of talented engineers at their disposal, can only match the budget offerings of the more established players. And the mainstream and budget markets are always the most cutthroat, with razor-thin profit margins and constant readjustment of price points, making for a hostile battleground for those wanting to enter the fray. And no matter how much money you throw at the problem, there's no substitute for experience, and that's especially true for driver development. At multiple points during my testing, I encountered performance problems that I suspected were the cause of sketchy drivers. The problem is dramatically worsened if you were to try Windows 2000 or XP. Most drivers for that OS family are outright broken, and when they work, performance is horrible. The PCI versions often have the same problems regardless of OS, on top of having hardware reliability and motherboard compatibility problems. One thing I can't complain about is software compatibility. With the right drivers, the Kyro series is as easy and problem-free as any card from ATI or Nvidia. Driver features are plenty, with a user interface very reminiscent of 3dFX tools, with lots of options to tweak image quality, toggle VSync, and even a feature to fake the presence of hardware transform and lighting, though I haven't run into a situation where this was needed. Rendering quality in games is spot on, and I've never encountered any graphical glitches or artifacts. And it's that smooth experience that makes these cards so compelling for retro gaming. Under Windows 98, they are strong performers in games from 2001 and earlier. While there's no tangible benefit in doing so, it's somewhat of a novelty playing games like Unreal Tournament with a silky smooth frame rate with a graphics card not made by the usual suspects. Unfortunately, if you want to run games made for older PowerVR hardware using SGL or SGL2 proprietary APIs, you're out of luck.
So what happened after the Kyro 2? Imagination Technologies did plan to release a follow-up, a tweaked version of the card called the Kyro 2 SE, or STG4800, which would have boosted the clock slightly to 200 MHz, but it was cancelled before making it to retail. A true next-generation product was planned, the Kyro 3, based on the STG5500 and PowerVR 4 architecture. It would have seen release likely in 2003 with 4 pixel pipelines, DDR memory, significantly higher clocks due to a 130nm process design, and yes, support for hardware transform and lighting. But it was cancelled after their manufacturing partner STMicro pulled out of the graphics chip business. The specs would have likely placed the card in the budget category for that year, but unfortunately we'll never know for sure. Sadly, no further PowerVR products would make it to the desktop PC from that point forward. Well, that would just about do it for this review. I hope you enjoyed my take on the Kyro series, and even if you didn't, please feel free to leave me a comment down below with your thoughts on it and the Kyro series in general. It's certainly an interesting line of graphics cards and one of my personal favorites. Until next time, thanks for watching. I'm Nathan, and this has been PixelPipes.